everybody. Today's topic, estimating with confidence. This is really the first in a three-part video series that's going to show you how to find confidence intervals when we're using samples to represent populations. The first video, the one you're watching now, is going to help you learn how to find a confidence interval for a population proportion using the Central Limit Theorem. Then a much shorter video will show you how to find a confidence interval using the bootstrap method for a proportion. And finally, we'll show you how to use the bootstrap method to find a confidence interval for a mean. So let's get started with our using the Central Limit Theorem. Let me show you the example that I've picked out for us. I took a look at the Pew Research Center and found an article about the way Americans view and experience family and medical leave in the United States. There's my shameless use of a baby to make my video a little bit more attractive. And what I'm noticing, without really paying much attention as I scroll through here, is a lot of percentages. These are all percentages that Pew is claiming are true about adults in the United States and their opinions about various things. What we know is that when we see these, though they're making a claim that this is what applies to a population, these numbers came from samples. And so we have to take sampling variability into account. In other words, there should be some margin of error for these estimates. That's what finding a confidence interval is all about. So we're going to focus on this. 69% of U.S. adults say that fathers should have paid maternity leave. So just one particular estimate at a time. Now, before we get started with finding the confidence interval, I think it would be bad for me to ignore the fact, or to just gloss over the fact, that the sample is very important, how the sample was collected, the source of the data. So I'm going to say a couple of things. One is that we should really learn something more about the Pew Research Center. What's their mission? What's their slant? How objective are they? Should we trust that they're using scientific methods? Those are important things to know. Where's the data coming from? Where's the information coming from? And the second thing is, we hope that somewhere they tell us about their methodology. And here's a page where they do. Now, we're not going to go through the sampling, how they avoid sampling bias, how they avoid non-sampling sources of bias, what are the exact questions, and things like that. But those are important questions. That's just not what we're about right now. One thing we are going to notice here, though, is this fact, and that is that the results that they're publishing are based on a sample of 2,029 adults age 18 or older in the United States. So how do we use this information to get a confidence interval for the population proportion? So here's the question that I said we wanted to focus on. What percentage of adults in the U.S. agree that fathers should have paid paternity leave? So our goal is to estimate the percentage who agree with a margin of error. And the method that we use is that we gather data from a sample. Actually, Pew gathered data from a sample, and we're going to find a confidence interval using what we've learned about the Central Limit Theorem. Step one is to compute the point estimate pi hat from the sample. As we said, that was already given on the website. That's the 69%. If you were doing your own study and that value wasn't just given to you, then you might have to do a calculation that looks something like this. Pi hat equals, well, there were 1,400 U.S. adults who said that they agree that fathers should have paid paternity leave out of a total sample size of 2,029, and that's where the proportion of 0.69, the percentage 69%, came from. So either way, we also want to note the sample size is 2,029. Step two is to choose a confidence level. How sure do you want to feel about the estimate that you give in the end? 95% is pretty common, but there are different reasons for choosing different confidence levels, but it is a choice. And we're going to choose 95% right here. That means the critical z-star value is 1.960. That's going to tell us how many standard deviations we're using in the sampling distribution that the Central Limit Theorem predicts for us. Step three, find the standard error. And this is the part where we are really using the Central Limit Theorem, because it tells us if we were choosing from a particular population over and over and over again, how much variation could we expect there to be from sample to sample? This is the key idea that helps us to measure, in some sense, sampling variability. So the formula for the standard error is pi hat, 1 minus pi hat over n, and we take the square root of the result. So we've just got to substitute in the numbers. Pi hat is 0.69, sample size n is 2029, and when I do that calculation I get 0.0103. So that's the standard error. The standard error helps us to find the margin of error. So this is step 4, and that is to find the margin of error by multiplying the number of standard deviations times the standard deviation. So 1.96 times the number that we just found in the previous step gives us 0.020. So this tells us, and really this is the most important thing that we're learning here, is that the margin of error for the original estimate is about 2%. So now we find the confidence interval limits, and in this case the arithmetic is pretty easy. When we subtract the 2% from 69%, we get 67%. 69% plus 2%. Notice I'm doing it as proportions though. So there are the confidence interval limits. In fact, this is the confidence interval, 67% to 71%. And then it's important that we communicate this effectively. It helps to make sure that we understand what it is that we're saying, but it helps us to tell other people what it is that we've learned as well. So we want to interpret this confidence interval for them. So we always include a statement like this one. We are 95% confident the percentage of all adults in the U.S. who agree that fathers should have paid paternity leave is between 67 and 71%. Yes, the point estimate was 69, but that was based on a single sample. This statement indicates that with taking into account sampling variability, we are very confident, 95% confident, that the actual proportion of all such adults is between 67 and 71, somewhere in that range. So it tells us how far off we might be due to sampling variability. A statement like this always has several parts. Make sure you include the confidence level so we tell people how confident we are. We know that the choice of confidence level affects the margin of error, so we'd be making a different statement if we change the confidence level. But also, if we don't tell people the confidence level, how do they know whether we're 10% confident or 99% confident? So that seems important to tell people. The context is important, including the parameter. So what I mean by the parameter is just saying it's a percentage that we're estimating, not any other kind of number. And the context is that we've surveyed adults in the United States who agree that fathers should have paid paternity leave. So we're being very specific about what we're talking about. Of course, it's important that the confidence interval itself appears in this statement. That's the 67 to 71%. And finally, we really want to make sure, I don't think I can emphasize this enough, that the statement we're making is about the population, not the sample. So the word all adults in the U.S. Is a way of indicating to myself and to you that we're talking about a population, not making a statement about the sample anymore. We've used the sample in order to make this much more valuable statement about the population. Well, that's all we wanted to show you in this case. If you have any questions, let us know.